Welcome, and we've just been talking about function composition, and in mathematics, whatever we do, we want to be able to undo. So for addition, we have subtraction. If we have multiplication, we have division. If we have exponentiation, we have logarithms. More on that to come. But with function composition, if we compose a function, we want to be able to decompose a function as well. Okay. In other words, if we have a function like we have here in h of x, that's already composed, we want to be able to decompose it. We want to undo that. Okay, so we want to find two functions such that when we do f of g of x, right, which is that fog looking thing, okay, maybe I'll just write this a little bit better. F of g of x. So we insert g into f where such that we get this 4x squared minus 1. Now, honestly, this is a lot of trial and error, okay? And it also takes a little bit of mathematical vision, okay? What I tend to do is I say, well, okay, think about order of operations. Maybe sometimes that's helpful. So we notice we have an x squared, so according to PEMDAS, right, exponents come before multiplication and division. So maybe maybe I could say that f of x. So if I think of this whole thing as something squared, what would I have to square to get to 4x squared? Well, that would be 2x, right? So I could really view this as like 2x all squared. So I could say, okay, well, g of x again goes into f. G of x, I'd have to insert 2x, okay? And then what would have had to exist there before g of x was even involved? Well, this whole 2x was really symbolizing like an x, okay? Because again, x was being replaced with 2x. So x squared minus 1, okay? Now, this is my answer. And again, if I wanted to check, I could just literally do the composition. So f of 2x, right? And then this would be 2x all squared minus 1, and distribute the square to both things, 4x squared minus 1. It ends up working, okay? Now, these are my answers. Your answers may not be unique, meaning like you could have one thing, your friend could have another set of things, and that's totally possible. Another kind of silly example, another silly way to break this down could be to say that f of x is 4x squared minus 1, and g of x, this is really silly, it's just x, right? Because you're saying, okay, when you do the composition, f of g of x, right, you're inserting x, so g of x is x, right? Insert that into your f of x function, so this is just 4x all squared minus 1, which is 4x squared minus 1. So there's another set of two functions. Again, this is the silly decomposition that you could use, but these would also satisfy the conditions as well, okay? Next example, okay? Find two functions where f composed with g gives you this h of x function. Now this one could be a little tricky. Yes, the silly, you could do something like f of x is equal to square root of x minus 1 over x, and then g of x is just x, and then again insert g of x into f and you get the same thing. Okay, that's fine. This is basic and we can do better. Okay, so let's do better. F of x, g of x. Okay, this one might take a little bit of vision. The example that comes to mind for me, and maybe you have something else in mind, is that if we have maybe say, if we look at the numerator, right? In the numerator, the square root of x is kind of unusual, right? So maybe instead there used to exist an x there, okay? Well, if this was x, then, and then this became x after the operation is done, I think we needed an x squared there before. So what I'm saying is maybe let g of x be x or square root of x, and then if g of x is square root of x, I'm claiming that x minus 1 over x squared is f of x. And so this is my claim. Let's check it. So f of g of x, right? So this is f of square root of x. Okay. And then, so this is my f of x function. So square root of x minus 1 over square root of x squared. Yep, that gives me square root of x minus 1 on the numerator. Denominator, the square and the square root will cancel, and I just get x. Okay, so this example does work. Okay, there are variations that you can do of all this. For instance, you could try, say, g of x is equal to square root of x minus 1 and just let it be the entire numerator. Then your f of x function would shift a little bit. You'd have to have x in the numerator and then x plus 1 in the denominator all squared. And I'll let you verify the arithmetic, but that one will work as well. So again, decomposition is not unique. And you may need to come up with multiple, or you may need to try to find different ones. But regardless, to check that your decomposition works, always go back through and do the composition.